You think quantum reality is strange because it's complicated. You imagine tiny particles doing bizarre things. You imagine equations breaking common sense. That picture feels safe because it keeps you outside the problem. You think the world is out there, finished, waiting to be observed. You think measurement is passive. You think reality exists first and knowledge comes later. This is wrong. You've been told quantum mechanics is confusing because it's incomplete, because physicists don't understand it yet, because we're missing a deeper explanation. That story is comforting. It lets you believe your intuition is still basically correct. Bohr didn't believe that. He thought your intuition was the mistake, not the math, not the experiments. The unsettling part is this: quantum theory doesn't attack reality, it attacks how you think reality should behave. And once you see what Bohr was actually saying, your mental picture doesn't get clearer, it collapses. You rarely notice this assumption because it feels too obvious to question. You believe the world exists before you look at it, that objects have properties even when no one is watching. That observation is something added later, like a spotlight revealing what was already there. This belief is so old, so deeply embedded, that it doesn't feel like a belief at all. It feels like the definition of reality. If you leave a room, you don't think the furniture becomes undefined. If no one measures the temperature outside, you don't imagine it stops having one. Reality in your mind is stable, complete, self-contained. Physics was built on this picture for centuries. Classical physics doesn't merely allow this assumption, it depends on it. A planet has a position and a velocity at every moment. A stone follows a path whether or not anyone traces it. Measurement just uncovers facts that were already true. Quantum mechanics is often presented as a technical problem layered on top of this picture, as if the classical world is still there, intact, and quantum theory merely adds fuzziness at small scales. This is wrong. Bohr didn't see quantum mechanics as a correction to classical realism. He saw it as a warning that the classical picture was never fundamental. The experiments didn't suggest that particles behave strangely. They suggested that the idea of behavior without observation was being quietly assumed and quietly violated. Consider what you mean when you say something exists. You don't just mean that something influences the world. You mean it has properties, a position, a momentum, a trajectory, a state that can be described independently of how it's found. But quantum experiments keep producing a specific, uncomfortable result. Whenever you try to treat these properties as pre-existing, the predictions fail, not approximately, not philosophically. Experimental's move was not to invent a new hidden picture underneath. It was to question whether the picture itself was justified. He noticed something subtle that most people still resist. Every statement you make about a physical system relies on the conditions under which that statement becomes meaningful. Position is not a thing floating in space. It's defined by an arrangement of rulers, detectors, boundaries, reference frames. Momentum is not an internal label carried by a particle. It's defined by a different arrangement, one that excludes precise position. You don't discover these properties, you set the stage for them. This is where the discomfort begins. If properties only make sense within specific experimental conditions, then the idea of a system having all properties at once, before measurement, starts to dissolve. Bohr didn't say reality disappears when you look away. That would be an easy misunderstanding. What he said was more unsettling. He said that asking what a system really is, without specifying how it is observed, is not a deep question. It's an undefined one. When you hear the word measurement, you imagine something gentle, a glance, a reading, a passive act that extracts information from a system without disturbing what was already there. This picture feels obvious because it works everywhere else. You measure the length of a table. The table doesn't care. You check the time. The clock doesn't change because you looked. So you carry this intuition into quantum mechanics, and it quietly breaks everything. Bohr realized that the word measurement was misleading us. In classical physics, measurement reveals properties. In quantum physics, measurement establishes the conditions under which properties can be spoken about at all. This is not a technical distinction. It is the core fracture. Every quantum measurement requires a macroscopic apparatus, detectors, screens, counters, objects that obey classical rules well enough to define outcomes unambiguously. You cannot remove this apparatus from the description. You cannot treat it as a neutral observer. The apparatus is not a window, it is part of the phenomenon. This is where most interpretations try to escape. They imagine a deeper reality beneath the measurement, one where the particle already had definite values, and measurement merely disturbed them. Bohr refused this move, not because it was impossible in principle, but because it smuggled classical assumptions back in through the back door. Think carefully about what happens in a quantum experiment. You don't simply ask, where is the particle? You build a device that defines what where means. A screen gives you position, but it destroys information about momentum. A different setup gives you momentum, but position dissolves. This trade-off is not about technological limits. It is not about clumsiness or noise. It is structural. The experimental arrangement does not uncover a hidden attribute. It selects which attribute can meaningfully exist. This is why Bohr insisted on describing experiments in classical language, not because classical physics is fundamental, but because outcomes must be communicable, recordable, shared. A measurement is not a peek behind the curtain. It is the creation of a context, and here is the part that feels hardest to accept. There is no description of the quantum system without that context. When people say, what was the particle doing before it was measured? Bohr heard a question with missing information. Before which measurement? Under what conditions? With what apparatus? Without those answers, the question doesn't point to a hidden truth. It points to a category error. You are trying to describe a phenomenon while removing the very framework that makes description possible. This is why quantum theory feels evasive. It doesn't tell you what is. It tells you what can be said, given a specific experimental situation. Bohr wasn't denying reality. He was denying the idea that reality comes with labels attached, waiting to be read. And once measurement stops being passive, the idea of an observer, independent list of properties, quietly falls apart. You carry a mental picture of particles as tiny billiard balls. They have positions. They have velocities. They are, whether you look or not. This picture is comforting. It makes the world predictable. It feels real. Quantum mechanics demolishes it, not by breaking rules, but by refusing to allow the rules to apply in the first place. Bohr noticed something unsettling. A quantum object does not possess all its properties simultaneously. Not just, we can't measure them at the same time. They don't exist in the way your intuition demands. Take position and momentum. You imagine a particle moving through space like a marble rolling across a table. It has a path, a speed, a definite place at every instant. Quantum reality refuses that story. Set up an experiment to measure position precisely, and momentum becomes undefined. Set up to measure momentum, and position becomes undefined. This is not a limitation of your tools. It is the structure of the world as Bohr understood it. Quantum objects do not carry pre-existing labels. They are not things with hidden values, waiting to be discovered. They are defined by the context in which you engage with them. Think of it like a color-changing chameleon, but more abstract. The chameleon doesn't choose a color independently. The color emerges only when a specific light shines. Quantum objects aren't wearing colors underneath. There is no underlying color to reveal, only the context that creates the appearance of one. Every property, position, momentum, spin, exists only as a phenomenon tied to a measurement arrangement. Remove that arrangement, and the concept of the property evaporates. This challenges one of the most basic assumptions you have about the world, that objects have intrinsic qualities. Bohr framed this refusal not as strangeness, but as a principle. We must be clear that it is meaningless to speak of the attributes of quantum objects independently of the experimental context. Your classical intuition wants to push back. It wants to believe the particle is still, somewhere, when unobserved, still moving, even when not measured. Bohr's insight is relentless. There is no still somewhere, no still moving. To ask such a question is to step outside the bounds of meaningful discourse. Quantum objects are not hiding secrets. They are not incomplete. They are not tiny versions of your macroscopic expectations. They are phenomena that only manifest within precise conditions. And accepting this begins the slow collapse of every classical crutch you have leaned on: path, trajectory, state, certainty. You may have heard about complementarity and imagined it as a simple choice: look one way, see one aspect; look another way, see a different aspect. It sounds almost innocent. Two perspectives on a single underlying reality. A way to peek behind the curtain from two angles. This is wrong. Bohr's principle of complementarity is not about hidden facets of a pre-existing object. It is about mutually exclusive conditions for meaningful description. You cannot combine them because they define reality differently. It's not two slices of the same cake, it's two entirely different cakes. Consider the classic example: wave and particle. You might think the electron is secretly both, and measurement merely chooses which side to reveal. You are imagining an electron with dual personalities, secretly complete. Bohr would disagree. There is no both waiting to be uncovered. Wave behavior manifests under one experimental arrangement. Particle behavior manifests under another. Try to force them together, and the concepts collapse. Complementarity is a law of conditions, not a law of underlying attributes. It says to ask about momentum in a position measuring setup is meaningless. To ask about which slit in a two-slit experiment while preserving interference is meaningless. This destroys the comforting intuition that reality is a single, fixed entity you can dissect piece by piece. Reality is not something divided into independent properties. It is defined in the interplay between the system, the experimental conditions, and what can be meaningfully said. Think of it like language. The rules of English work in certain contexts, the rules of mathematics work in others. You cannot simultaneously demand both in the same sentence without nonsense. Complementarity is like that, a strict framework for meaning. This abstraction begins to strain your imagination. It forces you to abandon the mental picture of an object as an entity with a complete set of labels. There is no electron with a position, momentum, spin, and wave function lurking beneath the surface. There are only phenomena, each fully defined only in its own experimental framework. And yet, these phenomena obey precise, predictable rules. Bohr's insight is subtle. Reality is not arbitrary or random. It is conditioned, structured, observable only within the constraints that allow meaningful statements. The more you internalize this, the more your classical crutches, the idea of pre-existing properties, paths, and definite states, start to dissolve. You begin to see that quantum mechanics does not describe a strange hidden world. It describes the limits of what can exist as a phenomenon. When people talk about quantum mechanics as weird, they almost always point outward. They imagine the universe itself is strange, particles jumping through walls, cats both dead and alive, spooky action at a distance. You think the problem is nature, that reality is bizarre, irrational, almost deliberately perverse. This is wrong. Bohr saw the problem differently. The weirdness is not in nature, it is in your classical expectations. The strangeness arises when you try to apply macroscopic intuitions to phenomena that do not conform to them. Quantum mechanics does not bend reality, it exposes the limitations of your mental model. It shows that your assumptions about objects, properties, independence are inapplicable at the fundamental level. Consider entanglement. You hear about particles influencing each other faster than light. You imagine a hidden signal, a cosmic trick. You imagine nature breaking rules. Bohr would tell you, the rule you are trying to apply, local separability, was never guaranteed in the first place. Entanglement is weird only if you insist on thinking classically. Once you accept that properties are contextual, that the system is defined in relation to measurement, the weirdness is merely a misapplied intuition. The fatal mistake is trying to find the missing explanation underneath. A hidden variable, a pre-existing trajectory, a secret classical world. Bohr's insight, the search for such an explanation, is not futile because it's hidden. It is futile because it is conceptually ill-posed. The world is not weird. You are. Your mental frameworks are too rigid. Your insistence on objects carrying pre-existing labels is the true source of discomfort. Quantum mechanics confronts you with this fundamental humility. Your most basic intuitions about objects, causality, and independent reality are not universal. They are emergent, classical, approximate. And yet, within its own rules, quantum theory is exact, consistent, and beautifully predictive. The universe is not mocking you. It is asking you to reconsider the very terms you used to describe it. Einstein refused it. He could not accept that quantum mechanics required giving up a deeper mechanical picture. He wanted reality to exist independently, with all properties defined, whether observed or not. He clung to determinism. Causality, the comforting idea that the world is fully knowable. Bohr, by contrast, gave up something radical. He gave up the insistence that nature had to fit classical categories. He accepted that asking about the state of a quantum system without specifying the measurement context was meaningless. Not because it was unsatisfying, not because it was incomplete, but because there is no deeper mechanical layer that can answer that question. This is subtle. It is not surrender. It is discipline. It is intellectual honesty in the face of evidence that your intuition is wrong. Imagine trying to describe a landscape with words that only apply to flat terrain when the land is mountainous, with cliffs and ravines. Einstein insisted on forcing the language. Bohr accepted the limits of language and described only what could be consistently communicated. He recognized a strange paradox. The more you try to preserve classical intuition, the less sense quantum theory makes. The more you accept that classical ideas fail, the more coherent reality becomes. Bohr's willingness to give up the classical crutch reveals the quiet power of restraint. It is not that nature is incomplete. It is that your mental model was never complete. And the philosophical consequence is profound. Certainty is not a property of the world. It is a property of the questions you can meaningfully ask. By releasing the need for an underlying, true state, Bohr opened the door to a reality that is not layered, not hidden, not preordained. It is relational, it is contextual. It exists only where phenomena are defined. This was a move Einstein could not accept. It is a step many of us still resist. It is also the step that allows quantum mechanics to function flawlessly without invoking incomprehensible metaphysics. You have always imagined a backstage, a place where the world continues in secret, where particles carry labels, trajectories, histories, silent, hidden, complete, where the universe really is, and observation merely uncovers it. Bohr removed the backstage. There is no hidden room behind the phenomena, no pre-recorded script, no objective reality waiting to be read like a book. Reality, in the quantum sense, exists only within conditions that allow it to be experienced, not because it vanishes when unobserved, not because it is mystical, but because the question of what exists is meaningful only in a context. Position, momentum, spin, they are not inherent properties. They are relational. They are phenomena. They emerge only when the conditions for their definition are met. This is disorienting. It is not incompleteness. It is absence of a classical crutch. The world is not a set of pre-defined labels. It is a network of relations, of contexts, of what can be meaningfully said. And yet, within these conditions there is law. There is predictability. There is beauty. The universe is not chaotic. It is structured, precise, and astonishingly coherent, but in a way that defies the classical intuition you assumed was universal. Think of it like music without a stage. The notes exist only in performance, in context, in relation to each other. There is no hidden sheet music beyond what is played. Bohr invites you to see the world this way, not to comfort you, not to explain it fully, but to shift the ground beneath your assumptions. Once you accept this, your classical picture, the universe of things with pre-existing properties, dissolves entirely. And in that void, reality is not less real. It is more profound. It is a world without a backstage, a world in which phenomena are the fabric of existence, a world where observation does not intrude, but defines, a world that forces you to reconsider what it means to say something is, and in that reconsideration, you glimpse the quiet awe that Bohr always pointed to, a reality that is not out there, waiting, but a dance of possibilities made tangible by conditions of experience itself. You cannot return to your old intuitions. And that is precisely the point.